In this video, I'll show you how to simplify expressions using trigonometric identities. This is part 2 in the series. Starting with question 1, they ask us to simplify the expression shown here. You'll notice that nearly all the terms here are reciprocal trigonometric functions. Secant theta is 1 over cosine theta. Cosecant theta is 1 over sine theta. And cotangent theta is 1 over tangent theta. So let's replace all of these with their normal trigonometric function. This becomes 1 over cosine theta minus 1 over sine theta over 1 minus 1 over tangent theta. Similarly, tangent theta is defined as sine theta over cosine theta. Now, since tangent is in the denominator position, 1 over tangent, we can replace this whole thing with the reciprocal of its identity. So we have cosine theta at the top and sine theta at the bottom. Now just remember, if that was tangent, then we would replace it with this. But since it's 1 over tangent, it's the reciprocal. The next thing that I'll do is find a common denominator here and a common denominator here. Combining these two terms, we get sine theta minus cosine theta over cosine theta sine theta. And what I did is I multiplied the two denominators together and then multiplied sine theta with 1 and cosine theta with negative 1, and that's what it gave me. That's the numerator. In the denominator position, we have 1 minus this, and once again I'll find a common denominator. The common denominator here would be sine theta, and at the top we'll have sine theta times 1, which is sine theta minus cosine theta. Now what we have is two fractions being divided to each other. Imagine if we had 1 over 2 divided by 3 over 4. What you would do is you would flip the 4 and the 3, and you would change that to multiply. So let's do the same thing. Let's keep this fraction the way it is. That's going to be our 1 over 2, if you will. And this will become sine theta over this expression. If we do that, we should end up with sine theta minus cosine theta. Remember, this part hasn't changed. Multiply 2, the reciprocal of this, and something very special happens. This term and this term are the exact same, so they can be cancelled out, leaving us with sine theta over cosine theta times sine theta. Next, this sine and this sine will cancel out, leaving us with 1 over cosine theta. And the reciprocal function that represents this is secant theta. That right there is the final answer that represents our original expression. Let's move on to question 2. In question 2, they ask, simplify the expression so that it contains only sine and cosine. We have cotangent squared x plus 1 times secant squared x minus 1. What you may not notice right from the get-go is that both of these binomials are Pythagorean relations. Here's what I mean. The Pythagorean identities are 1 plus cotangent squared theta is equal to cosecant squared theta, and 1 plus tangent squared theta is equal to secant squared theta. So if I bring this term over and I replace this with cosecant squared theta, here's what happens. Cosecant squared theta, that switches, times, and I told you I'm going to bring this 1 over, making it secant squared theta minus 1, I end up with tangent squared theta. Now this is really important for us because tangent squared theta can be replaced with sine squared theta over cosine squared theta. And this can be replaced with 1 over sine squared theta. Notice that this sine and this sine will cancel out, leaving us with 1 over cosine squared theta, giving us secant squared theta. But of course, the question wants it in sine and cosine, so this is good enough for me. And so there you have it. 2 more examples on how to simplify expressions using trigonometric identities. Make sure to watch part 3 for some more challenging examples.